In this video, we'll look at how to solve linear inequalities in one variable. So much like linear equations, our goal is to isolate the variable using a similar process as we did for linear equations. So we'll isolate the term that has the variable first on one side of the inequality by adding or subtracting. Then we'll use multiplication or division to make the coefficient of that inequality 1. Any fraction that we have, we can clear out using similar methods as we did before. There is one big difference, however. In the case that you are multiplying or dividing an inequality by a negative number, so if the coefficient of the variable is negative, or for some reason you want to multiply to clear fractions and you're multiplying by a negative or dividing by a negative, in that case, you have to change the direction of the inequality symbol. So less than would become a greater than or equal to would become a less than or equal to. Let's take a look at the example. So here we are beginning with the inequality negative 5x is greater than or equal to 30. Normally, if this were an equation, we would divide by that coefficient negative 5, and we are. But because we're dividing by a negative 5, in order to maintain the truth value of this statement, we have to flip the inequality symbol in the opposite direction. So this greater than or equal to becomes a less than or equal to. We divide the same way. Negative 5x divided by negative 5 is positive x, and 30 divided by negative 5 is negative 6. If you don't flip the direction of your inequality symbol, you actually are finding the complement of the solution set. All right, so let's take a look at these examples. We're going to practice solving, but also practice using our set builder notation and interval notation. The first one is negative 6x is less than 30. So this is very much like the example that we just talked about. So we just have one step to isolate x here, and that step would be to divide by negative 6. Now, since I'm dividing by a negative, I have to flip the direction of my inequality symbol. This inequality symbol is less than, so I'm going to rewrite it as greater than. So I have x is greater than negative 5. So I could take that and translate it directly into a set builder notation. The set of all x such that x is a real number, x is greater than negative 5. So just the inequality that you received as your solution is your description in set builder notation. And it's really important that you don't lose the inequality there, because negative 5 is not the solution and it does not work for this statement, and there are many, many other solutions. So really the entire solution is that inequality itself. Let's also practice graphing, and then from the graph we can translate that into an interval. So we have one variable, so we're graphing on a number line. You could put any value in the center of your number line, and number line is infinite in both directions. So I'm going to put negative 5 at the center of my number line here, and just to remind myself of numbers that are higher than negative 5 and lower, I always like to mark one number above, one number higher. So this would be negative 4, and one number lower, negative 6. And when I say one number, I'm doing one integer. All right, so negative 5 is not included in my solution set because it's not equal to, so I'll have to use parentheses at negative 5, but I don't know which direction yet, so I won't draw that first. Since x is bigger or greater than negative 5, I'm shading the values to the right of negative 5. Okay? As we go to the right, we get larger. And my shading is going to keep going. And like I said, since negative 5 is not included, we're using parentheses. Now the graph is helpful because the graph allows us to get the interval. So the interval takes the smallest number, so the number furthest to the left in the shading, which is negative 5. Negative 5 is not included, so I'm putting parentheses around it. And then I'll put the largest number in the shading. Since this goes on to positive infinity, going to put that infinity symbol here, and with infinity we always use parentheses. So here once again we have set builder notation, graph, interval notation. Let's take a look at the second example. So in the second example we have a variable in more than one place. So we're going to use a similar strategy as we had with linear equations. I want to get the variable on one side and the constant on the other. Now if you want to kind of think ahead, to avoid that rule that you have to flip the inequality symbol, you may want to keep the coefficient for your variable positive, but it's not necessary. Alright, so let's take a look at number 2. So again, you have 4 options here. You could add or subtract 4 different terms. I am going to decide to subtract 3x because maybe I want to think about avoiding that rule where I change the direction of my inequality. So this would keep the coefficient for x positive. 4 is greater than or equal to 2x minus 8. Since I moved the variable to the right, I'm going to move the constant to the left. So I'll add 8 to both sides. 12 is greater than or equal to 2x. And notice that my coefficient is positive, so I'm dividing by 2 and dividing the other side by 2. 6 is greater than or equal to x. So this would be my solution. And I will write that in 3 ways. First, set builder notation. The set of all x, my variable, such that x is a real number. And then I could just rewrite my inequality symbol, or my inequality statement. Now, in order to maybe assist you with the graphing, I'm going to rewrite the statement so that the x is on the left-hand side. You have to be a little bit careful here. Because unlike an equation where you could just switch the sides, you have to worry about the direction of the inequality. So this statement reads, 6 is greater than or equal to x. I want to rewrite an equivalent inequality, x is less than or equal to 6. Right? If 6 is bigger than x is less than 6. So if I change the order of the 2 sides, the expression on either side of the inequality symbol has to get flipped as well. These have the same meaning. All right, now that helps me with my graphing. So I'll put 6 in the middle, go 1 integer above, 1 integer below. I want the values for x to satisfy these inequalities. So the x's have to be smaller than 6 or equal to 6. And the values on the left are smaller than 6. Since 6 is included, I'm putting a bracket at 6, and I'm shading all of the values that are smaller, everything to the left. That shading continues, so I'm putting the arrow at the end of my shading to show that shading keeps going as far as my number line goes. Now I could use the graph to get the interval. The interval always takes the smallest value, or the value furthest to the left in the shaded region, which would be negative infinity. With negative or positive infinity, we always use parentheses, comma, the largest value is 6, that's included, so we put a bracket around it. Again, you can check that your graph is correct, or you can check that you've solved correctly. Any value that you pick in this shaded region should work for the statement that you have. So we could pick 5, or we can pick 4, we could pick 0, or we could pick negative 10 if we want. All of those values should work in this statement, and any of the values that are not in the shaded region should not work for that statement. So if you do want to do a check, I would pick a number that's in the shaded region. I wouldn't pick the endpoint because you want to be careful. Sometimes that's included, sometimes that's not. So to be safe, if you want to check, pick something in that shaded region and it should work. All right, for the third example, we see parentheses. So we'll proceed as we have done in the past. When we have parentheses, we'll open them up using the distributive property. All right, so I'm going to distribute on both sides at the same time just to clear out the parentheses. So multiplying by 3, I have 3x minus 6, and then plus 5 is greater than, distributing with 4, 4x plus 4 plus x. Now we'll combine like terms that are on the same side. On the left, 3x minus 1 is greater than, and then on the right, 5x plus 4. Now once again, I have to add or subtract any of 4 different terms. If you like to have the variable on the left-hand side and you always want to do that to help you with your graph, then certainly do that. So I'll do that here. That may make my inequality, or my coefficient, I should say, negative. So I will have to remember that rule. So I now have negative 2x minus 1 is greater than 4. We'll go ahead and add 1 to both sides. Negative 2x is greater than 5. So I'm dividing by negative 2. So I have to remember that rule, which is to change the direction of my inequality symbol. And I almost didn't do it there. So it was is greater than, now it is less than. My fraction is not simplifiable, if that's a word. I can't simplify it. I will write the negative out in front, so this is negative 5 halves. Right, so no big deal, we're allowed to get fractions. Fractions are real numbers, they live in the number line. Let me write this as a set, the set of all x, such that x is a real number, x is less than negative 5 halves. And then close my set notation bracket. Graphing that, negative 5 halves, we'll just put that in the center, and then get a sense of what is higher and what is lower. One thing you could do is to think about this as a decimal. Negative 5 over 2 would be negative 2.5. So if you wanted to put integers on either side, negative 2.5 is exactly halfway between negative 2 and negative 3. You could do that. You could also just increase your or decrease your numerator by 1. So if I increase my numerator by 1, make it a negative 4. This would be negative 4 over 2, which is equivalent to negative 2. And then decrease it by 1 makes it a negative 6 over 2, which is the same as negative 3. So you can write them in fraction form or integer form or decimal form, whatever makes sense for you. I'm just going to leave them in fraction form. All right, so that fraction is not included, so I will use parentheses, and I want values that are less than it. So parentheses here, shading to the left. My shading is going to keep going, parentheses, and my interval goes from negative infinity with parentheses around it to negative 5 halves. Negative 5 halves is not included, so I'm using parentheses there. And again, if you wanted to check, you could pick a number in the shaded region. Here, negative 6 over 2 is equivalent to negative 3, so you can plug that in and you should get a true statement. So the number on the left-hand side should be bigger than the number on the right-hand side, right? The two numbers are not going to be equal, because to make this true, you need to compare the two numbers with that correct inequality symbol.